Bismillahirrahmanirrahim. Today we are going to discuss the term that resonant modulus. Actually, uh, with modification uh, in H2 method, the road bed road bed strength is now taken in terms of a resonant modulus. It is also a subgrade material stiffness test. What do you mean by a resonant modulus? Is to estimate its modulus of elasticity. Unlike the modulus of elasticity, we know that is a Hooke's law or Young modulus. This modulus is measured in 3 dimensions, while the Young modulus is measured in a unidirectional. So that's the difference between a resonant modulus and the elasticity modulus. Another thing you will find that in terms of when you calculate Young modulus, most of the time, all the strain, it's a direct relation between stress and strain. It's a linear relation, and all the strain are recoverable after we remove the load. But in terms of resilient modulus, some of the strain is lost. That's why it's called a resilient modulus of elasticity. So there is some resilience by the sample as well. What happens is how we test is that we make a standard specimen and we subject it to a repeated cyclic stress of fixed magnitude, load duration, and cycle duration to our cylindrical test specimen. In case of the material testing, there is always we test in a very cyclic manner. What I mean by cyclic manner, we apply load for some duration and then we stop that load and try to assess the behavior once the load is removed. That is, once the material is subjected to some load and once that load is the load is reduced, the load is taken back, how material behaves. It is very similar to what happens in a field. A motor vehicle, it passes through a point and it creates some deflection. And since it's a dynamic in nature, the vehicle pass on to the other point and that load is removed from that point and now shifted to other point. That's why whenever you test the specimen of highway, whatever is the layer, be it asphalt layer or be base layer or sub-base layer or subgrade layer, they are always subjected to cyclic loading. And the reason is very simple because in case of highways, we actually we have a dynamic load, not a static load. Now, how this three resilient modulus test is performed is that the sample is, once specimen is made, it is confined in a chamber where it is free to move vertically while axially along the circumference it is confined. when I say confined, it doesn't mean that it is confined by a steel cylinder, like we had in CBR test. Actually, what happens that the sample is there's a sample and the sample uh, is not in the mold. It is outside the mold. It's a cylindrical sample, and at that around that sample there is a water. So whenever the load is applied, the the material tends to uh, shrink. And what happens that since we have that there is a water around that sample, this sample make it reverse again, make it shape once we start applying the load. So what we do in this sample is, as I was saying, that there is a vertical load sigma 1 that is applied, and since this plate is fixed, so once you apply the load, this load as a reaction comes along, and it's a cylindrical sample, so there is a loading, and this loading uh, around the circumference of the cylinder is either sigma 3 and sigma 2. Sigma 3 applies a compression force. As a result, there is a tensile force. So as a whole, the net stress is the difference of sigma 1 and sigma 3. Because they are in opposite direction. And at the same time, there is strain, because modulus is always stress and strain. And since this is a resilient modulus, that's why we have uh, more than one stress. And there is a epsilon, and this epsilon is recoverable strain. Because soil is not a perfect elastic material, it's not a rubber. Whenever you stretch and whenever you release, if you are dealing with a rubber, all the strain, all the original length will be recover. And after cycles of cycles, then you will find some permanent strain. But as the case of this soil, what happens that when you remove the load, some of the strain is not recoverable. I would say the load has created a plastic strain. So that's why we keep on applying that, we'll have, recoverable strain as negligible as it could be. So the purpose is to measure stiffness, obviously determine the load capacity of the material. It is just, in highway pavement structure, all layers are tested for resilient modulus, or actually in HMA it is known as is there is another form that is a dynamic modulus as well. So it's a similar to what you know about the triaxial test, and it is always nowadays it is used in every method of pavement design, be it H2 or some other method of pavement, because it simulates the actual bearing resistance of the soil. Now let's see the test specimen. This is a frame, And within the frame, there is one more frame. And with that frame, we will call this as a loading chamber. And here, this is a linear vertical displacement transducer. Linear vertical displacement transducer is just like a dial gauge in terms of CBR machine. So actually it measures the strain, and it is around, it measures in terms of micron meter. Such is the sophistication, such is the preciseness of this linear vertical displacement transducer. And there is a load set. Obviously, whatever load you applied, it is transformed into pressure, and this load cell will give you that load. And there's a chamber, and within that chamber, you will see LVDT are also connected to measure the strain that is being created within the soil. And then there is obviously a clamp to hold that LVDT. This gray one is the sample, and this blue one is some plate, you see, in which the sample is placed. And between this sample, this gap, there is a water, right? So there is a top platen, bottom platen, there is a LVDT clamp, there is a soil sample, there is a side road, and there is a chamber. So this is how machine and electrode wise, if you look at this machine, this is what the triaxial test equipment is well. Now what happens is that, try to understand this diagram. At the start of the test, we have always a stress of time. As we start applying the stress, we apply the loading. And what happens that once we release the loading, after this point, the sample has recovered. But since this is not rubber, this has not touched the bottom axis. At the start of the test, it was zero, but it has recovered. It has not regained all its strain, and that's how there is a gap. And if you look at this scenario, if you talk about the strain time diagram, we start applying load, the strain increases, and then what happens that up to this point, there is always, when we unload, all the strain is not recoverable. And most of them converted to plastic strain. And the time will come when you will have this straight line. It means the soil has stopped taking the load. It's just like, God forbid, is the angiogram, what you see. That's in the heart measurement. ECG is just like an ECG. God forbid if it has become straight, then you have people who have died. So that's why your sample has died. So this is the stopping point. So as you can see, since this is stress strain, we are interested in recoverable strain. Right? If you look at this thing, there is a load and stops, then we have a rest period, then we apply the load. Recoverable strain is the change in length per unit length, you always know. And this is the another pictorial of a resonant modulus test. People tend to confuse between triaxial test and resident modulus test. It's in a triaxial test, there is a cyclic sine curve type loading. While this is not sine curve loading, it's just uh, UDL type loading or something like that. Or we call hammer sine loading, inverse sine loading. Uh, if you look at this thing, we started the test, we reach at this point, we leave this test, this sample has not recovered. Some of them has done plastic. Again, we start from this point. This is now my initial point. I start loading, I go to the peak, and then I release. Again, we have not, every time, each of the cycle, I have not regained the original position within, within the vertical scale. If it have been rubber, this value, every time, this will be my value. But since it is not rubber, you will have accumulated plastic strain. So we can say that MR is the abbreviation of resident modulus. M for modulus, R for resident. Is the elasticity modulus based on recoverable strain under repeated load and is defined as the ratio of stress and strain. But the stress is geometric stress and strain is the recoverable strain. And again, I repeat, the difference between the elasticity modulus or Young modulus and the resident modulus, we applied X load on all around, three-dimensional loading. While in plasticity modulus, Young modulus, there is a unidimensional loading only on the z-axis. So it's the material resident modulus provides a mean of characterizing pavement construction materials, including surface, base, and subbase, under a variety of temperature and stress states that stimulate the conditions the pavement subjected to moving wheel load. The test provides an excellent means of comparing the behavior of pavement constructions under a variety of conditions: moisture, density, gradation, and stress states. And if you want to compare it with the CBR test, again, if you compare it with the CBR test is the unidimensional test. Again, the CBR test, you don't test at different temperature. You test at room temperature. Here you can have variety of things. So that is another advantage of having high resolution modulus test. You see, in the CBR test is an old test. There's something what we call empirical thing. It depends upon the size of the sample, something, and now as compared to this is a mechanistic behavior of material. Material stress strain is defined in this type of test. So there we have stress and strain, CBR, but it was not strain like it was just as unidimensional, and it was dependent on too many constants, too many assumptions. Just facing a dead load, facing a surcharge load, testing after 4 days of soaking. So these are the tests. As compared cost-wise, there is a little more test is more costly. The little modulus test that cannot be performed in the field as easily as the CBR test, right? And you need people, you need training, you need sophisticated software, and for to accept the fact it comes in dollars, we need lot of exchange, and then we have to train people, and then we are dependent on the computer. And if God forbid the computer gets something wrong, you have to reinstall and you have to, the vendor, you have to contact the vendor and he will charge you again. This is, the money one. Now, the behavior of resident modulus, there is a different behavior for different types of soil. Now, if you test the coarse grain soil, then your resident modulus is defined by this relation, right? K1 times theta times K2. K2 is the slope of the line, and it is, drawn on logarithmic scale. Theta is the bulk stress, that is the addition of all the stress value, sigma 1, sigma 2, and sigma 3. And K1 is the constant. You do not start at 0. There is some starting value. What happens is how you do it is very simple. You test the coarse grain soil and you will never get start. You will have some values. Why? How you do with it? In this type of test, we do conditioning. We don't start the test. What happens that we keep it in the sample for some time so that it attain, and we have, we have put the pressure on. We have applied some load. And what happens that we allow the soil sample first to get acquainted with the conditions. The water, the temperature, the loading conditions, the loading scenarios. And that's why when we start the test, your test always have some value. That's why there is a K1. If it would have been, a CBR test as I was explaining, it was starting just from the origin. And if it is not starting from the origin, we were applying some correction. So this is not the case with the resilient modulus test. We do sample conditioning and then we start actually doing the test. So overall, if you look at this scenario as well, you don't take, you don't test it 96 hours, but within this soil sample, you cannot do it in some hour. Still, it needs some time. First for the conditioning, then for the actual, again, to go with the sample preparation that we have to do. So, for example, what happens is that we applied a 5 PCI sigma 3 load, and sigma 3 load is from the water side, and we get deviator stress 5 psi at 200 cycles, and then we do it at 10 psi, then do it at 15 psi, and we just start testing at different deviator stress. Then we apply 200 cycles of load each. Now, unlike a coarse grained soil, this is not the simple intercept you get. You have this different type of curve. In case of coarse grained soil, there was, gradual increase. Here, this is this is non-linear behavior. So there are actually two type of slopes. You get K3 and K4. And obviously, again here, if you compare it with the coarse grained soil, the coarse grained soil was starting right at the origin for x-axis, and y-axis there was some value. But here, what's happening that resilient modulus, after sampling, it was at higher value, and gradually with stress it comes lower and lower. And not only that, the slope is not constant. There's one slope and so whenever you have been giving say soil sample, and actually what happens that and someone prepare a sample and say check this sample, and yes, or he or she has not told you, is not uh, you are not aware of what type of soil sample you are testing. So if you get this type of behavior, then you have tested a fine grained soil, and the other behavior that we have discussed before, it's a coarse grained soil. And then there is a formulation. Uh, it- it- so in case of fine grained soil, if you want to be like a coarse grained soil, then the relation is different. This is octahedral test, and octahedral test is a difference of two stresses, sigma 1, sigma 2, sigma 3. It's just like a Mohr circle you used to have in mechanics of solid. So this is the relation for fine grained soil. Now, the sample conditioning, unlike coarse grained soil, there were three conditioning stresses, 5, 10, 15. Here there is only one. And this is what we are discussing is the standard protocol, the ASTM standards that has been developed as to standards. So they have, with the experiment, they have seen that the soil may be tested like this. And again, the total number of loading cycles. This now we know that. So let's stop here.